right, thanks Ashlyn. I'm Jimmy Sibert with the City of Irving Water Utilities Department, and I'll be giving you kind of a brief introduction to this project and the exploration that we did to actually find out what we needed to do here. So a little history on this pipeline. It's a 84-inch pre-stressed concrete cylinder pipe that was installed in the early 90s or so. It's jointly owned by both the City of Irving and the North Texas Municipal Water District. And we transfer around 110 MGD through that. 50% of it is the City of Irving's and 50% is the North Texas Municipal Water Districts. The North Texas Municipal Water District gets their water at Lake Lavon, and the rest of ours is sent all the way over to Lake Louisville, and also about a third of our supply we sell to Upper Trinity Regional Water District, and that's their sole supply for their Harpool plant. And so this water supply is a pretty critical because of that, because it is their only supply for that treatment plant. This exhibit just gives you kind of a big overview of this alignment. It's around a 45-mile pipeline that starts at Lake Chapman. You can see on there we've labeled where we cross the South Sulphur River, and this is where we did the repair that we'll be talking about a little bit later. You can also see we do have it labeled on there, Lake Lavon. That's about where North Texas gets their water, and then Lake Louisville is where we get our water. One of the things that you can see in this exhibit is that it's a very rural alignment, and a lot of the line is difficult to access, that there aren't a lot of it is in fields and out in kind of forested areas, so it can be difficult to see a lot of this pipeline from the road. So we have been trying to get out and do aerial surveys. So we'll rent a helicopter and send one of our guys up in the helicopter to take photos of the alignment to see if there's anything that sticks out. And if you remember, May 2015 was one of the biggest rains we've had here in a long time. And those of us that work at municipalities know we had lots of issues around that time. Well, June of 2015 is when we did one of the aerial surveys of our Chapman water supply line, and this is what we found. So when we saw this, we knew immediately that this was an issue. This was not at all the way that it was designed. You can see that there's lots of riprap around there. There had been some reinforcement over the pipeline at one point, and there was actually about 4 or 5 feet of fill over it. Well, all of that riprap had been eroded away, and the top of the pipeline had been exposed. And so we immediately began talking to the landowners around here to be able to get access to this, because our easement itself wasn't very accessible at this point. So by July, we'd coordinated with the landowners and got out there to put our feet on the ground and take a look at what we needed to deal with here. At this point, we weren't even sure if we could keep the pipeline in service or if we needed to shut it down or just how bad the condition was. So July, we actually got out there on our feet and saw that the river had actually undercut the pipeline and was going underneath. We brought half with us as well. They were working on another pipeline replacement on this project with us. So we had them come out so that they could work with us to come up with a design to fix this. So we began working on plans immediately after that last one, and when we first went out there in July. By February, we visited the site again with 60% plans and had a few contractors come out with us as well to talk about how we would actually come in and do this repair. And one of the things to note here, I'll actually flip back in just a second, but if you see that pile of rubble, that was on the edge of the bank before. You can kind of see it where the guy in the blue is standing is that pile of rubble. So that was where the bank was in July. By February of 2016, it had cut back that much further, and another joint was exposed, and it was being undercut in another place as well. And with that, I'll let Ben get up and talk a little bit about the design.
Thank you, Jimmy. So I'll touch on some of the issues we ran into, considerations in the design construction phase. first of all, Jimmy mentioned the criticality of the supply to their customer, Upper Trinity Regional Water District. And so we knew, assuming we could keep it in service, and which we certainly wanted to do, we were limited in how long it could be out of service, limited really to 2 or 3 weeks because of its status as a sole water source to one of the Upper Trinity Regional Water District's treatment plants. And so our first order of business was to stabilize the existing pipe, protect it as best we could. We were aware that there is some beam strength inherent in pre-stressed concrete cylinder pipe, and in fact, if you look at the AWWA manual for concrete pressure pipe, you'll find a photo that should have put it in here, but you'll find a photo that shows pre-stressed concrete cylinder pipe, large diameter, hanging in a sinkhole 4 or 5 joints worth. So we know there is some beam strength inherent, but we wanted to get that pipe stabilized as quickly as possible. And so once we made that next site visit in January and February of 2016, saw how much erosion had occurred since really a lot of that erosion we assume occurred during the really bad rain events we had over Christmas break in 2015. If you recall, that was the year we had the big tornadoes that came through Garland and Rowlett. And so we think a lot of the additional erosion that had occurred since the previous summer was due to a lot of that rain. But because of that, the district and the city put the project really under emergency basis, bid it based on our 60% design. And so from that point, the project almost became a design-build type of project, just in terms of a lot of the coordination we had. There was continued erosion throughout the construction process as the channel continued to erode. We kept having rains. In fact, you'll see another photo from spring of 2016 after the contractor got working the river up basically at its banks. So because of the continued erosion, there was a lot of back and forth between the contractor. Garney Companies was the contractor selected to perform the work, and the engineers and the owners in terms of how to account for that additional erosion as we went along. So the project started, from my point of view, started as a pipe protection project, and that's what I'm familiar with as pipelines, but it pretty quickly grew into an erosion control project. And so I'll mention, I know I saw Jim here. Jim is a structural engineer that had on the project. We also had Stephen Crawford, was our HAF's H&H engineer that worked on the project. I didn't see Stephen come in. I asked him to sit at the front so I could deflect questions to him, so I know Jim's back there, so Jim wave at me if I say anything wrong. But yeah, it really became an erosion control project, and our first order of business was to stabilize that existing pipe, but after it was stabilized, we wanted to protect it into the future, and that meant stabilizing the channel, providing control against future erosion. And so some of the other issues, and I'll talk about some of these in the next couple of slides, but access to the site, and in fact, I'll go ahead and talk about that. Let me get this turned on. So the pipeline, the river crossing is that point right there, and the nearest public road crossing, the pipeline is in an 80-foot wide water line easement. The nearest county road crossing to this river location is that point right there. And that's about a little under half a mile to the west. The easement to that point was pretty overgrown since it had been built 20 plus years ago with brush and some small trees. And so it had to be cleared out just to get to the site from that side. Additionally, the county road leading to that point for about a mile was unimproved. And so just in order for gardening companies to get equipment to the water line in order to start clearing to get to the river crossing, the county had to come out and pave that existing county road, put down flex base. On the east side, the nearest county road crossing was several miles away, and so the district worked with the landowner on the east side to get temporary access, and that became our initial access to the site to perform the initial stabilization. A couple other issues regarding access. Of course, the limited access we had, in order to finalize our design, we needed geotech investigation performed, and so we had to have those access roads in order to get our geotech down to the site to perform our borings and finalize our structural design. So here is the ultimate design that we came up with. The pipe is, of course, the blue line that you see there. We looked at options as far as pipe replacement and what we could do if we could lower the pipe to get underneath the current flow line of the channel. And ultimately, we came to the realization that no matter what we did from a pipeline point of view, it wasn't going to negate the need to stabilize the channel and prevent future erosion. And so that's why I say it ultimately became an erosion control project. We ultimately built an erosion control structure over the pipeline. So what you see here are sheet piles that have been driven, there we go, sheet piles driven across the river on both sides. And we filled between those sheet piles, laid a concrete riprap drivable surface at the top, just enough to get a couple of feet of cover over that existing pipeline and protect it from future erosion, and installed rock riprap upstream and downstream, sufficient to prevent the river eroding around those sheet piles. And so the end result, we have a little bit of a dam in the river, just a couple feet above grade at the upstream side, and 4 feet or so above grade on the downstream side to ensure low flow is continued on. One other aspect I'll mention as far as what went into design is environmental issues. We're crossing a river, and essentially we're putting a dam in a river, so there was definitely environmental permitting involved from the Corps of Engineers. We coordinated with the Corps early to talk with them about our concept, to minimize the time that was going to be required for the permitting process. We actually did this work under 2 different nationwide permits. We used a nationwide permit 12 for the access roads because a lot of the, pretty much for a couple thousand feet in each direction is floodplain and some wetlands. So we used nationwide permit 12 to permit the access roads, which essentially were used for utility line maintenance. The access road on the west side is going to be a permanent maintenance road for the district and the city. The access road on the east side was designed as temporary. The portion outside of the wetlands, the landowner actually worked with the district and asked to leave in place. So outside of the floodplain on that side was left in place. But nationwide permit 12 for the access roads, and then the stabilization work itself was done under nationwide permit 3. And interestingly, at least from my point of view, the nationwide permit 12 did require a little bit of mitigation. The nationwide permit 3 for the channel stabilization work itself did not require any mitigation. So, but the Corps was very, very helpful, actually got that permit approved pretty quickly under the nationwide process. And then one other permit, we did have the permit through Texas Parks and Wildlife for aquatic species relocation for all the fish and turtles and other aquatic species that we had to move out of the way in order for the contractor to do his construction. So with that, I will turn it over to Jeff Hogan, who's going to kind of walk through the construction process with us.
It's going to be interesting. I'm old school. That's the point?
Yeah.
Okay. Well, thank you, Ben. Moving into the construction, as Ben noted, the first order of business was getting that pipe stabilized, that aerial crossing there. Before that, we had to build an access road, and we had some struggles getting geotech in there because it was so wet, it's wetlands, and so that that was a challenge. Once we got the road established and the stabilization of the 84-inch PCC pipe, we also began clearing the west easement that Ben referenced, and we got permission to leave 10 of the 18 feet of that flex-based road, and then we contributed funds to a mitigation bank per the Corps agreement. So there's the biologist, the environmental scientist that Ben referenced, transferring fish. You can see some concrete there already. There was, the original idea was to form it up and have, a designed structure underneath the pipe. But what we found is just voids that were deeper than we anticipated, and Garney actually came up with a solution to lean the concrete. Is that correct? We used leaner concrete and just pump what we needed to have under there until it surfaced. And they would use, well, there's the May rain event, and that contributed even more erosion to the project. But thankfully it didn't damage the pipe. The pipe was active the whole time. So we asked HAB to do some calculations, and what Ben referenced is the beam strength that the pipe had. It withstood this rain event. So Garney has finally established a crossing. You're looking at the west. You're looking west right now. I believe you can see the pipe right there. So they're moving back and forth, doing some grading along the bank, establishing some riprap. Pardon me. Here we're moving into the sheet piling. And once we obtained the geotechs along the river, HAF was able to finalize the sheet piling design, which took those sheet piles all the way to weathered rock. And how deep did we go? On average, 35 feet deep in some locations? Maybe 30, I can't remember, but various different depths. The contractor cut off the remaining, what was sticking up, and the finished product you'll see look really nice. So riprap and riprap. Lots of riprap. Even from the design that Ben showed you, the footprint actually expanded a bit because the erosion was more significant, and it worsened as the project went on. We're getting close to the finished product, if not the finished product. The existing 84 inches right there on this side. There's some cutout curbs to allow the water to come across, and then there's room, theoretically, hypothetically, for another pipe should we find that necessary. So I got to really applaud HAF Associates. They came up with this idea very quickly. We thought we were going to have to relocate, bore another line underneath the river and have a connection, and the cost would have been greater. But Ben and Tony Almeida came up with this idea. Almost there. There's another shot. Kind of a monolith. Whoops, I'm ahead. That's Ben's. I don't want to steal Ben's thunder. He's going to make some acknowledgments, but I want to mention working with the city of Irving, Jimmy Sibert, Steve Pettit, David Johnson, we're a pleasure to work with. Sometimes Larry Patterson and his people from Upper Trinity Regional Water District were in there. Garney was really a partner in this. Folks there are David Burkhart, Sam Marston, Superintendent Jeff Riddle, and then Mike Swift after they sent Jeff up to Colorado. Sheet piling contractor is Shannon Gregory out of Stephenville. Concrete guys are LKT and Associates. Garandona did the surveying for Garney, and a company by the name of AMX did the clearing. So with that, I think I'll send it back over to Ben.
All right, I'll just wrap up with some other acknowledgments. Of course, North Texas Municipal Water District and City of Irving. And the city's customer opportunity regional water district was very cooperative throughout the whole process and understanding of what needed to be done. I'll mention that Garney Companies was great to work with on this project. They came armed. Anytime we had erosion issues that came up as construction proceeded after any rain event, they came armed with ideas that we were able to analyze and sort through and get resolved. And again, I'll mention that the Corps of Engineers was helpful in getting those nationwide permits approved quickly, as well as Texas Parks and Wildlife, Hunt County as well, preparing that county road. And the landowners, we didn't mention this, but we did have easements from the landowners on both sides of the river. And one was very cooperative, one was not as cooperative, but we do appreciate their cooperation through the process, giving us access, and then the construction and the easements. And there was something else I was just thinking. I will mention, Jeff mentioned Tony and myself from HAF. I'll shout out to Pat Acker as well, helped come up with that concept that we came up with. And not on the list also, but Food Grow Consultants was our geotech on this project. And finally, I want to thank Ashland for giving us the opportunity to present, and ASC Dallas Branch, thanks for your attention. So with that, we will do our best to entertain any questions that you have. So thank you.